So, uh, so we have learnt about symmetry elements, symmetry operations, the point groups, and last class we also learnt about the different how do we identify subgroups, classes, the, conjugates and classes. All those things we have already discussed. So that was an approach based on just you look at the molecule. आप एक 3D मॉडल को लेके आप कैसे उसको रोटेट करते हैं, रिफ्लेक्ट करते हैं, एंड आपको रिजल्ट क्या आता है, वो अकॉर्डिंगली आप वो यू डिफाइन द मल्टीप्लिकेशन ऑफ द प्रोडक्ट ऑफ टू ऑपरेशंस. सो वो सब आपने देखा था. नाउ व्हाट वी आर गोइंग टू लर्न इज दैट each of these operations, symmetry operation, can be represented by a matrix, right? So a basic knowledge of matrix algebra is essential at this point. Many of you who have maths in 11 12 class, class 11 and 12, you might be aware of matrix. uh, mat- so matrix is a singular, and matrices, when we say, that is plural. So matrices, जब मैंने title में लिखा matrices, it is means a large number of matrices is called matrices, right? So matrix, as we know, it is a rectangular array. So you can say you have numbers like 1 2 3, several numbers placed in a form of there is a pattern of keeping them together, like in a rows, and horizontal rows and vertical columns. So this kind of array is called, so capital A here is called a matrix, which is has so many elements, so many elements A11 A12 arranged in rows and columns. So ये जो arrangement होता है इसको matrix कहते हैं in mathematical terms. So uh, so definitely, so here you can see that n number of rows and m number of uh, m is the number. So when we say this is also m by n matrix, because there is m number of rows, this matrix is m by n. So m is the number of rows and n is the number of columns. So ये बेसिक है. अब तो बहुत सारी इंफॉर्मेशन इस मैट्रिक्स में कंटेन की जा सकती है. सो देयर like so there are number of ways in which these matrices can be made. So one of the ways is so when we write row number I, say, then when I is equal to row number I has elements of different columns 1 2 3 up to n. So that's how it is written. Row number 1, so A1 and column 1. Row number 1, column 2, so A1 2. Row number 1 and nth number of columns, so like that. So a given number AMN represents m number of rows, n number of column, right? So if this is the, so there are two things in one row. यहाँ पे देखिए ith number of ith row, so this will have I1 I2 I3 up to nth number of columns. So you go to the all columns and then label it like this. If you have to look at a column, then you will think of so the rows, number of rows is changing 1 2 up to m, and j, that this part is constant, j j j, like that. So you can see similarly here, when you are looking at a column, say this column number 2, you'll find that 2 2 2, this second one is the fixed, the first one, which is the representing the row, number of row, that is changing 1 2 up to n. So each matrix has rows and columns which defines the size of the matrix. if a matrix just now we had discussed this, m rows and n columns, so the dimension or the size of the matrix is then denoted by this. So dimension या size, ये term हम use करेंगे, which is m by n. Okay, so matrix which is by n, which is a m number of rows and n number of columns, is denoted like this. Okay, you can write like this. So each entry, whatever is written over there, is called an element of the matrix, which we will call element of the matrix or entry of the matrix. Both we can use the term. Aij is the general way of putting this. So I is the row number and j is the column number of that particular element. So this is, so when you start practicing, you will learn many of the things like this. Okay, so think of how we arrange make up a matrix out of, in a general life. If you have to put it like this, you can take another example, but here I am taking example of a bookshop. So suppose uh, sale of books, inorganic chemistry books by different in sale of books in a shop with in different quarters. So 1 year divided into 3 months, Q1, Q2, Q3, Q4. सो 3 मंथ्स का एक क्वार्टर होता है, तो कितनी सेल होती है? सो आपने जेडी ली Q1 25 23, so just like that. बुक्स बाय जेएमसी हुई 5 10. So just suppose a shop has a different sales record of these 3 books. So we are arranging, we are putting this in terms in rows and columns, and this is a matrix. This makes up a matrix, right? तो इस तरह से हम किसी भी चीज के बारे में सोच सकते हैं और एक मैट्रिक्स बना सकते हैं, ठीक है? सो इफ if one wants to know how many inorganic chemistry books written by J.D. Lee were sold in Q4, we'll go along the row number, this first row, and column which is Q4. So straight away this point, and find that it is sorry it is to Q4 JD Lee. Yeah, so like that it will be like this. So in a similar way you can think of anything and you get the information. So writing this, so this is how I make up my matrix. Each row and so they represent the type of books sold in different quarters, how many copies were sold. So that's so similar thing you can put it for any other things. And so this kind of matrix which we are showing here, 3 rows and 4 columns. So size of the matrix is 3 by 4, and each of the elements, so a 3 by 4 is equal to 27. That's how we can put it. Okay, so different types of matrices that we will encounter. Vector. A vector is a matrix that has only one row or one column. So this, as you know, vector has magnitude and direction. So this, when we put it like this in a form of matrix, so we are putting the same information, the x, y, z coordinates. So 3, so kind of thing, x, y, z will put in what column, and we'll call it vector. And vectors can be of two types. A row vector, only along row you will have certain elements. So this is an example of a row vector, a type of matrix in which there is no there is only one row. So what we have here is only one row. So like this is a row vector, and so this is example of that. And this will, we say that it has dimension of 1 2 3 4 5. Another example of second type of vector that we will encounter, matrices that we will encounter is amongst the vector matrices, is column vector. Column vector will be appearing like a column from top to bottom, uh, like this. So, and the dimension, so if 1 2 up to n number of rows but only one column. So column vector is something having only one column. So only one row, that was row vector in previous case, and in this case it is only one column. That's what. So example of a column vector that we have just seen. Yeah, so here it is of column vector of dimension 3. So we have three elements arranged in a form of row, sorry, column here. Then we also encounter square matrices, square matrix. So square matrix means the number of rows and columns are equal. M is equal to n. That is the case of we. So the elements which appear along the diagonal of the matrix, we call it diagonal elements of the square matrix. Sometimes in many cases you will have diagonal matrices are also called the principal or main of the matrix. Actually this will become very important, the diagonal elements, in when we move into the representing symmetry operations through this square matrices. It will the diagonal elements which will become very very important. The rest of it is not doesn't matter much, but this is so principal or main, so we'll see that importance when we deal with them. So the example of square matrix is here. So 3 rows 3 columns, you can clearly see that. So this is your first row first column a11, this is a first row second column, this is a first row. Similarly, this one is A21 second row, and this is A31. So you know how to notations work. A11 25, A22, like that. So this is how you represent these things. Then we also have examples like it's a very special kind of matrices, upper triangular matrix. In this case, you see, it will appear like, just have a look, the numbers which are non-zero numbers, if you collect them together, it will appear like a triangle. So in the upper half, so you have look at the diagonal, and above the diagonal you have non-zero elements. Below that line diagonal you have 0 0 0. So below the diagonal entries are 0, above the diagonal we have non-zero entities, and we call it upper triangular matrix. Lower triangular matrix is the other way around. It has numbers below the diagonal, you have the numbers upper, on the upper half you have all zeros are there. So all the elements above the diagonal are 0. Yes, somebody typed something, I can't see your message. Huh. 1 0, लेकिन उसके ऊपर आप यहाँ पे देख रहे हैं ना, ये जो है ना, सो डायगोनल के ऊपर हमें देखना है, डायगोनल के ऊपर सारे एलिमेंट्स 0 हैं, नहीं सारे, दे आर नॉन जीरो एलिमेंट, सो इट इज अपर ट्रायंगल। इस साइड में लेकिन सारे नीचे की तरफ सारे 0 हैं, डायगोनल से नीचे, सो इट इज, हाँ, एक एक है ना, लेकिन सारे नहीं है ना। वी आर, इफ इट इज ऑल एंट्रीज बिलो द डायगोनल आर 0, देन वी आर कॉलिंग इट लाइक दिस। और दूसरे ऊपर वाले में आप देख रहे हैं यहाँ पे अभी लोअर ट्रायंगुलर मैट्रिक्स, सो एक एलिमेंट 0 हो सकता है, लेकिन सारे एलिमेंट तो 0 इधर नहीं है ना। ये डायगोनल वाली लाइन है और इसके इधर ये सारे, देयर आर सर्टेन नंबर्स, सो बट अबव द लाइन हियर एवरीथिंग इज 0। सो वी जस्ट लुक एट कि एक जो मेन लाइन है डायगोनल लाइन के ऊपर के अगर सारे 0 हैं तो वो लोअर ट्रायंगुलर होगा, और इसके पहले वाले एग्जांपल में नीचे वाले डायगोनल के नीचे सारे एलिमेंट्स 0 हैं तो वो अपर ट्रायंगुलर होगा। जस्ट वन नंबर उससे मैटर नहीं होता. So it is whenever you have this kind of thing, you call it upper triangular matrix, lower triangular matrix. So these are the things. Diagonal matrix, सबसे स्पेशल केस जो हम एनकाउंटर करेंगे सिमेट्री एंड पॉइंट ग्रुप्स में, ये वाला केस होगा. Diagonal matrix is something that is the most important for symmetry purposes. You will find this because in this case it is a square matrix with all non-diagonal elements equal to 0 and is called diagonal matrix. So so pretty simple. The example, you look at this, the diagonal, this is your diagonal, and above and below. ठीक है, आपने दो एग्जाम्पल देखा. इसके पहले था कि डायगोनल के ऊपर वाले नॉन जीरो एलिमेंट्स थे, डायगोनल के नीचे नॉन जीरो एलिमेंट्स हैं, और यहाँ पे है कि डायगोनल के दोनों साइड, ऊपर और नीचे, सब जीरो हैं. ओनली द डायगोनल्स हैव नॉन जीरो एलिमेंट्स. So when the diagonal elements are non-zero, उसके अलावा non-diagonal elements are all are zero. That's what you see. So such a matrix you have, it is called diagonal matrix. Diagonally सारे non-zero elements हैं, बाकी ऊपर नीचे सब all are zero. So any or all the diagonal entries is so अब जैसे अभी आपने पहले देखा कि कोई एक एलिमेंट इसमें जीरो हो सकता है, यहाँ पे देखिए जीरो वाला, तब भी हम इसको डायगोनल मैट्रिक्स से कह रहे हैं, because on the diagonal we have one zero, so one of the entry can be zero, one or any or all the diagonal entries of diagonal matrix can also be zero, can be zero. Okay, so identity matrix. Identity matrix is something which has all diagonal elements. So it is a special case of diagonal matrix. A diagonal matrix having all elements 1 along the diagonal. This one. You see? So ये जो दिख रहा है, this is called identity matrix. And this will be important for your identity operation, when we call represent it. Zero matrix, all entries, so it is easier to, so all the elements are zero. So A, B, C, so different types of zero matrix, 3 by 3, 2 by 3, 3 by 4, like this. So you can see all this. Okay. Then some of you may be familiar with addition and subtraction of these matrices. So we can perform these operations in like so you have 2 by 2 matrix. So addition will proceed like matrix 1, 2, matrix B is equal to C. So let's see how it happens. So matrix A, this is capital A, this is capital B, gives you C here. So how we achieve that? So when both are having same number of rows, same number of columns, so that's how you can see A11 plus B11. So this is what you are seeing here happening, right? So this becomes your first thing, first row, first column. So take the element from both A and B, A11 plus B11, that becomes the C11. So this is your C, right? Like this. Similarly, you go for the second element, first row, second column, A12 plus B12, you get C12, and in this manner you continue, and you can add up all the things, A21 with B21, so it gives you C. So things like this. So इस तरह से कनेक्ट करके आपको सारे एलिमेंट्स मिल जाएंगे. So this is how we proceed with addition, and subtraction will also follow a similar pattern. And so you must see that in this particular case, the same dimension, the dimensionality of the two matrices must be same. And when we it happens when we only then if the dimension, so 2 is to 2 by 2, both A and B matrices are having two rows, two columns, we say that they have same dimensions. Or in other words, we can also say that they are conformable for addition. If the dimensions are different, then we say that they are non-conformable for addition. Addition cannot be performed if the dimensions are different. There are two important properties of matrices, matrix addition, that we can note. A plus B is equal to B plus A. That is we say that the addition is commutative. And A plus B plus C, three matrices, if they are combined, then A plus B, so within the bracket means you perform A plus B first and then add it to C. When you are writing B plus C as the within the column, you perform B plus C first and then add it with A. So both of these are found to be same, equal to each other, so they are associative. Another useful of matrix thing is the transposition, matrix transposition. So we have subscripts. Okay, so let's see with example. Transposition. So you just invert the j and k. So if j is the row and this is the column, k is the column, then the order changes to kj. Reversal of the thing. So that is called transpose. So for example, if this is q is the matrix q11 q12, these are the numbers, so initially we are putting it like this, then the transpose will mean that we take all this thing together. This thing is now here, q11. So the column has now become the row. Column becomes the row, first row of the, so so the second column becomes this row number 2, like this. So you have everything which was uh, first column first row now becomes like this, k and j. So that's how we put it. Or and we denote it this by putting a prime, this symbol apostrophe comma, which we say q prime is the transpose of matrix q. So subscripts in the transpose remain the same, they are just exchanged. This is a point to be noted. So it has for an example, let's see if it is the matrix w prime is this one, just we are changing this order. So this is a row vector, we have just seen it is changing into column vector. So when you are putting transposing a row vector tends, so this is all elements along a row in a single row, so this is called row vector, and this is a column vector. So like this, an order jj matrix is said to be symmetric if okay, if the transpose is equal to it, so this a prime is equal to a, then we say that they are symmetric. For example, let's look at this. you perform transpose. If we write the row as column 1.2 minus 5, so it becomes this one. And the same way you put the other thing, second column, make it the row, and now you see that it appears the same. So this is a square matrix, and the numbers are such arranged that when we arrange first column into first row, when we make a transpose like that, and second row at second column we put it like that, we find that it is appears the same. So we say that they are symmetric matrices when W and W prime appears same. So in other words, we say that transpose of transpose is original matrix. Transpose of transpose. And multiplication k into a, if you multiply with a scalar number, scalar k, then every element of that matrix is going to be multiplied. And then we will also turn to multiplication of two matrices, and so we'll see some of the okay, so we'll see some examples of matrix multiplication is important, that we will be doing more often. मैट्रिक्स मल्टीप्लिकेशन जब भी आप सिमेट्री ऑपरेशन परफॉर्म करेंगे, जैसे अभी हमने देखा मल्टीप्लाई किया था, मतलब दो sigma v with c2 sigma v, so that is all about matrix multiplication that we will be doing if we represent those things. So let's try to understand this. If you have a scalar, so वेक्टर का मल्टीप्लिकेशन हो सकता है मैट्रिक्स के साथ, या स्केलर क्वांटिटी का भी हो सकता है. Scalar का multiplication होगा तो each of the elements is going to be multiplied. Let's see. So suppose we are multiplying alpha with this matrix A, then each of the thing is getting multiplied alpha alpha like that. So this simple thing. So like this. So when we put half, so everything becomes half of each of the element become half of that. So when you have to multiply two matrices, you must see. So matrix A mn and matrix B of the order nr, then it will create a matrix C with when multiply this matrix C, you will get matrix C with m and r as the m number of rows and r number of columns. इस तरह का होना चाहिए. And so the thing is that you can also note that important thing to see here is that we are able to perform multiplication only when this thing. So look at this n and n. So column of A, so this is the number of column. So left, if A is to be multiplied with B, so number of columns and the number of rows A must be same. So number of columns in A and number of rows, so that is the same, only then multiplication is possible. And we are getting a new matrix with a different set of rows and matrices. So these are things that you see. जब भी मल्टीप्लाई करना है तो मैट्रिक्स को, तो उनका जिसको आप लेफ्ट ए, अगर इफ यू आर राइटिंग ए इंटू बी, देन बोथ शुड, इसका कॉलम and इसका rows, this should be same, and you will get. So that's what we are seeing, that if it has m versus, so only then that we are able to perform it. और कैसे होगा, let's see with example that it will be much clearer. ज़्यादा हाँ, So every element when we multiply, it will be like a element a I k is the row, so b is the, so let's see, let's try to see it like this example, with an example. So suppose we have to let's see by example. So a and b, so this is 2 rows 2 by 3, and this is 3 rows and 2 columns, m n n r, right? So this is same number of, so number of rows of 1, so this is your number of columns, and this is the number of rows, this is same. That's what, and so multiplication is possible, and the new one will have m m m by r will be the new matrix of the order, so 2 by 2, so you will get 2 by 2 matrix in this. So just perform the operation and see how it is done. So define their product. B is pre-multiplied, or we say that B is left multiplied by A. So the thing is like this. कैसे किया गया? Minus. So you are taking 2, this one, 2, 1. So every element is being multiplied. 2 into 3, 2 multiplied by 3, 1 multiplied by 2. So you are moving like this, okay, and 3 multiplied by 1, so you are writing it here, so 3 and 1. So this is your first one. So row into column, so this is what you have to keep in mind, row into column, and in this way you start writing all the things. So then you take this first row, first column, that's what we have done. And then if you take second row multiplied with this column again, 3, 2, 1, second row, and the same column, then you are getting 3, 2, 1, 3, 2, 1. So you are multiplying like this, and this makes up your thing. So you start with, take the row first and multiply with the columns, arrange them in form of, in this way, and you will get thing. Then you go to the next one, second first row, first column, then you multiply with the minus 2, 4 and 3. So in a similar way you perform this operation, 2 minus 2 with minus 2. So first, उसके बाद जब ये perform कर लिया आपने, then you again first row with second column, this is what you are getting. Then you will get this one, second row, first row with second column, that becomes your, you write there, and second row with second column. So this is how you have to perform and arrange the things, so that you get the result A into B. So it is important, many times A B and B A may not be equal in multiplication. Multiplication is not, you can verify this here. So what we have seen here, A is of order 2, 3, 2 by 3, B is of order 3 by 2, 3 rows and 2 columns, and the product is having a different set of rows and columns, right? 2 rows and 2 columns. तो ये मैट्रिक्स मल्टीप्लिकेशन में होता है कि जो ऑर्डर है वो चेंज, सो ये डिफरेंट है, एडिशन और सब्सट्रैक्शन से काफी अलग दिख रहा है इसमें पैटर्न. You can see this, right? So you have in addition subtraction we had to have both the matrices must have same number of rows and columns, but here we are only looking for the same number of rows and columns for A and B. If we are putting multiplying like this, same number of row of one should be equal to the column of the other, like that. And you can also see that when you perform this operation for the same set of matrix A and B, if you multiply B in the reverse order, B into A, the results are different. So B into A, you can clearly see. So if you perform B into A, so B is 3 by, so when you are multiplying B into A, remember you have to look for number of rows and columns, 3 rows and 2 columns, and A has 2 rows and 3 columns. So yes, we find that this column is equal to this rows, and so multiplication is possible. We say that they are conformable, BA in that order, B multiplied by A. Previously we have seen A multiplied by B, and now it is the, in this case, the new matrix 3 by 3 जो इधर का है 3 by 3, this is the new matrix that we'll get. So in the same manner you perform this operation and you will find that you are getting a different matrix here. So clearly we can see that AB is not equal to BA, and we say that it is not commutative. AB is not equal to BA, then we say that commutation doesn't follow here. एडिशन में था, सब्सट्रैक्शन में था, उसमें वहाँ पे एडिशन में कम्यूटेटिव रूल फॉलो हो रहा था, बट नॉट हियर. And we see that order is also different now. Here 3 by 3 matrix is obtained. So matrix multiplication AB is not equal to BA. That's not yeah, not commutative. We have just seen AB is not equal to BA. This is what we learned just now. Matrix multiplication is associative. In other words, ABC is, so when you perform the multiplication AB first and then multiply the resultant with C, or BC first and then multiply this with A, the results should be seen. Matrix multiplication is also distributive. That means A into B plus C should be equal to AB plus AC. So scalar multiplication is commutative, associative and distributive, but scalar means one number multiplied with a matrix, and if you multiply two matrices then it is associative and distributive but not commutative. We have just seen two matrices if multiplied they are not commutative, but if with a scalar number they are commutative also. So transpose of a product taken and okay, you can just see, yeah. If you multiply and take the transpose का मतलब क्या था, कॉलम को रो में, रो को कॉलम की तरह लिखना था. So transpose of AB is equal to multiplication of two things. So these are the few rules of matrix algebra which can be easily verified. I'm not going to all these things, ये सब दिखाया जा सकता है, but So multiplication can also be, you can expose yeah, exponentially. When you are multiplying again and again with the same matrix, then you can use like exponent a4, like 4 times same multiplication is being carried out. For square matrix, repeated multiplication, we can use that exponentiation exponent as 4. So we can see that to denote that number. So for square matrix, it is a matrix which is conformable with itself when you try to multiply a square matrix. So it is the other one should have also same number of rows, same number of columns. Okay, so now we turn. So once we have learned the basics of matrix algebra, we can turn also to understand the what are the matrix notation for symmetry operations, different types of symmetry operations. So when we use the Cartesian coordinates x, y, z, and they define the position, and so position vector can be represented. So just like you were putting an arrow in a in earlier we were showing it by arrow, the position of an object in a three-dimensional space, position of a particle, position of an atom or anything. So now that same position can be expressed through a vector which is written in form of matrix. So that is also we can define it. So if you know the xyz coordinates, you can put it like this in a column, uh, uh, x, y, and z values, and that will be your vector. So this is your position vector. That's what we can write. Or so this is the initial vector, and then when you perform symmetry operation, that is the symmetry operation will be reflected by another matrix, and so when we multiply this, we will get a new set of position vector. Resulting vector would be defined by a different. So what I mean to say is that you have initial vector that was xyz, and then you write a matrix representing the thing, and the final you obtain something. So example to this, let's see. So suppose we define our identity operation. If you are having, so we have just defined in a uh, slides previous slides, we have defined different types of matrices, and amongst them we also define diagonal matrices. And if the diagonal matrix has 1 1 1 along the diagonal and all the elements are 0, then it is called identity matrix, and which is something that we use for identity operation, unity matrix, identity matrix. So the effect is that when this matrix is applied to a position vector, जो एक्स वाई जेड कॉलम में हमने दिखाया ना, उसको अगर इससे मल्टीप्लाई करें तो क्या होगा? You multiply this, so we are multiplying the position vector. So this is your uh, initial vector is what representing the position. This is my position vector, and now when we are multiplying this with a matrix which is identity, right? So now you perform your multiplication, what you get? 1 into x, x, 0 into x is 0, so you will add plus plus, that will be 0. Similar 0 1, 0 into y is 0, 0 into 1, 1 into y. So like that, when you perform this operation multiplication of two matrices, you get the same thing. So it leaves the initial vector unchanged, and that's why the final vector is unchanged. It has x, y, z values remain the same. Okay, so that's why we call this type of so this is this 3 by 3 matrix, a square matrix where all the diagonal elements are 1 1 1, is what we call as identity matrix. to represent, this is used for representing the identity operation. Okay, so if suppose you have xy plane in which you have to, so यहाँ पे xy plane में, so if you was, so none of the coordinates was changed here, xyz remains same, so that is equivalent of something multiplying with 1, and so this unity matrix is equivalent of something that equal to 1 in normal algebra. ठीक है, उसी का इफेक्ट देख रहे हैं आप. अब इसमें if we have to perform reflection through xy plane, what do you expect? When you perform reflection through xy plane, x and y will remain unchanged, but the z coordinate will change. So during the reflection through xy plane, xy coordinates unchanged, remain unchanged, right? They will have not affected, but z coordinate will be reversed, but z will become minus z. Minus z, right? So to show that after, so when we multiply x y, that पोजीशन वेक्टर को जब हम मल्टीप्लाई करेंगे, तो ऐसा अगर हम मैट्रिक्स डिफाइन करें, ओनली z हैज टू बी चेंज्ड इनटू फ्रॉम प्लस z टू माइनस z, प्लस टू माइनस में चेंज होना है. तो यहाँ पे हम z वाला जो था x, this is representing my x when we multiply with x, so this last element, this along the diagonal we are putting minus 1. You perform the multiplication now, see 1 0 0, and if you have this thing, then you plus this is x, 1 into x x, 1 into y y, and minus 1 into z, so this is your minus z. So minus z, this thing is a way to write minus z is written as z with bar. Okay, so multiplication effect, so here only the z is changed, which is very clear. If you have a mirror plane, xy components will not be changed, but z will be reflected by z will become minus z. That's what reflection does. And so starting from identity matrix, you can build up all the symmetry operations. बहुत ध्यान से सोचिए, हो जाएगा. अगर हम कहें xz प्लेन से रिफ्लेक्शन करेंगे तो y चेंज होगा, plus y, so you can think of that happening. So in a similar way, if you say that reflection through a yz plane, reflection, if you perform reflection yz plane, what will change? In this, plus x will become minus x, y and z component unaffected, yz unaffected when we perform multiplication. So how should we write it? So that's how we define all these things. When you have to perform xz, sigma xz, मतलब xz plane है, so plus y will become minus y, and so we put जहाँ y वाली पोजीशन है उसके लिए, so we are getting this is your minus y, right? And when you have it, if it is a yz plane, plus x will become minus x, so you are putting minus 1 over here, and this one is your minus x, position is changed. So रिफ्लेक्शन जब भी करेंगे, एक कोऑर्डिनेट चेंज हो रहा है, जो प्लेन का कोऑर्डिनेट है वो अनअफेक्टेड रहेगा रिफ्लेक्शन में, राइट? सो कीपिंग दिस इन माइंड, वी कैन डिफाइन ऑल द रिफ्लेक्शंस लाइक दिस. ठीक है. इन्वर्जन में क्या होगा, जैसा मैंने क्लास में पहले भी डिस्कस किया था, इन्वर्जन और रिफ्लेक्शन, रिमेंबर दैट पॉइंट? मैंने कहा था कि inversion is different from mirror operation. Many people were confused at that time. So in this case, plus x plus y plus z becomes minus x minus y minus z. And so all of these minus 1 minus 1 minus 1 along the diagonal, all the elements will become. So this is a very easy thing to do, inversion pointing out. So when we write this, all the elements along the diagonal are minus 1. When you perform multiplication, so this is the matrix we are writing, and multiplying with the position vector, this is the initial vector for the defining the position of the that point, the object, anything. And so each of them has become now minus x minus y, this is minus z. So that is what is represented as putting a bar over them, right? So this is the matrix notations. And now you can also think, when you multiply 2 times inversion, means you getting this identical view. So think of the molecule, any molecule that you have, perform in inversion twice. That is equivalent of, in matrix terminology, it will mean multiplying these two matrices with each other, you get identity. You can prove this easily. Minus 1 multiplication, so minus 1 multiplied with minus 1, you will get equal to 1. So like that, each of this will change, and you will get unitary matrix, which is 1 1 1, like that. So this is what we will get when we actually perform this operation. So these are all, everything that we have, we can see by rotating a molecule, reflecting a molecule in through pictures. We can get the same result when we perform these operations through matrix notations. So uh, so these are the coordinates. So okay, I think we will do proper rotation. It is slightly different. We'll do this in the next class. Thank you. So symmetry operations, rotations we'll do tomorrow, maybe same time. Just say okay. Thank you.